Welcome to Homework Lib.
Hi, so over here we're asked to find the energies of the first, second, third, fourth, and fifth levels for the three-dimensional cubical box, where we're going to have the same length on all of the dimensions, and we are going to know that we're looking for the five lowest unique energies, considering different degeneracies that we're going to have. So first of all, the energy on a 3D box of a particle in a 3D box is going to be the following: h squared over 8 times m times the length. In this case, we can factorize the length since all of the values are going to be the same, times nx squared and y squared plus nz squared, where all of the nx and y and nz can have values which correspond to integers larger or equal than 1. That means that we need to consider the different values of nx squared and y squared plus nz squared in order to find the different degeneracies that we're going to have. First of all, the lower state that we're going to find is going to be the 111 state. Next up, we're going to have different combinations of quantum numbers 211, 122, 121, and 112. Remember that the notation over here is going to be the following. We're going to have the quantum number nx, comma, ny, comma, and z as a combination for labeling our states. So this is going to be the first energy level, the second unique energy level, which is going to have the degeneracy equal to 3. Now we're going to consider the next possible arrangement would be the 2 to 1, 1 to 2, and 2 1 2. Over here I'm going to put the value of nx squared plus ny squared plus nz squared. For the lowest energy, that combination is going to be equal to 3. Next up, this would be equal to 6. On this case, it would be equal to 9, and we're going to continue as follows. The next possible state is going to be the combination of 311, 131, and 113. In this case, the sum of the square of the quantum numbers is going to be equal to 11. This is going to be the third and fourth energy level. And finally, for the fifth one, we're going to have the combination of 2, 2, and 2, which is going to have a value of the sum of the quantum numbers equal to 12. So now with this, we have the diagram of the first five unique states that we're going to have. We are going to identify which ones are going to be degenerate. So over here, I'm going to erase this section over here to give us some space and to give directly the values for energies for each of the states that we're considering. So following the equation that we had, the energy for the first state is going to be equal to h squared times 3 over 8 times ml, with degeneracy equal to 1. For the second state, we're going to have that the energy would be equal to 6 times h squared over 8 ml squared. Sorry, over here I forgot the squared, with degeneracy equal to 3. For the third state, we're going to have that the energy would be equal to 9 times h squared over 8 ml squared, with degeneracy 3. For the fourth one, the energy would be equal to 11 times h squared over 8 ml squared, with degeneracy equal to 3. And finally, for the fifth state, the energy would be equal to 12 times h squared over 8 ml squared, with degeneracy equal to 1. And with that, it would be all. Thank you very much, and have a good one.